We going live again. LeetCode grind. Let's get it. Top right is my subscriber count. It's up like crazy from the first day. So the first day or yesterday I shot my 1,000 subscriber celebration, and my YouTube channel has popped off even harder since then. Jay, what's up? I'm gonna grind LeetCode questions. I dropped this pretty good video where I do a review on a UC Berkeley student and pretty much review their resume. And their resume was pretty good. I literally have no idea why their resume why they can't get interviews. So I dropped this video because I more want to crowdsource and figure out why this person can't get interviews. Where is it? Yo. So this person pretty much had a pretty good resume, and yeah, I'm just trying to figure out exactly why they couldn't get it, and that's why I posted this video. I'm gonna drop this video in the chat. Let me know why this person can't get interviews. Jay, I'm gonna start hitting some LeetCode questions. I want to do the one that I did yesterday real quick to just remember what was going on, because I hit a live stream yesterday. This was a pretty good live stream. Appreciate everyone. Bro, Jay, thanks. Appreciate you. I gave you a shout out in this video. Or I gave you a shout out in one of my latest videos. But let me do count number of good subrays. This is a good question. Count number of good subrays. Jay, audio is good, right? Or no? And then I'm gonna figure out everything related to the coaching and stuff. I'm gonna make a call to my coach friend during this call, and we're gonna figure out how to set up all the coaching stuff, and I'll probably do that live. I'm drinking a Vietnamese coffee. These coffees slap, so hopefully I get locked in from just drinking this coffee. I'm gonna add the chat to the side here, so you kind of know when I start seeing stuff. Is it better if I throw the chat here so that you can see when your comments go live, or you don't care about the chat there? Curious on your feedback there. Like, should I throw the chat here? Like that? Do you care about that? No, appreciate you. The channel has been going crazy. Thanks for supporting from day one. I'll never forget you and pretty much all the people who supported me from day one. Okay, who solved this question? I'm gonna solve this question quick. I solved this yesterday on a different account, so I just need to solve it again today. And I'm gonna try to get a couple special guests in. I want to the first two questions. Okay, the contest only. I'm gonna do the LeetCode contest today too, because one of the subscribers yesterday gave a really good strategy to improve at LeetCode questions. When does this contest start? Saturday at 6. Damn, sneezed. Okay, let's get into these LeetCode questions. And drop in the chat if there's any good LeetCode questions that you want me to do. I'm going to start off with this one. And then if I don't get suggestions, I'm just going to do other ones. And we're going to grind LeetCode for like a few hours here. we're gonna grind to. We're pretty much gonna try to grind to 1K problem solve, but this is gonna take like a few episodes. Right now, I'm at about 543. So I'm gonna move this while the chat is still less active, but it's here. So given an array nums and an integer k, return the number of good subarrays of nums. A subarray is good if there are at least k pairs of indices I, j, such that I is less than j. So the number of good subarrays. Here, let me do this. So I just need to. I know the algorithm to implement this, so I'm just gonna implement it quick because basically what we're gonna do is it's just a sliding window technique. So there's two things. We're gonna do a sliding window technique with a hash map. We do. So we're gonna do the sliding window technique plus hash map of frequency counts. One sec. Let me get a paper towel. So we're gonna do a sliding window technique with frequency count. So in order to do a sliding window with frequency count, what we're gonna do? Did we already do count number once? Let me do like an easy sliding window one quick. Just trying to look for a good question that I came across recently, and I just want to solve it. Where am I? There's what is this? Max consecutive ones too. Okay, I'll do that in a second. Let's solve this one first. Count the number of good subarrays. What we're going to do is we're gonna do sliding window with a hash map of frequency counts. So let's start the frequency count list. Yo, Alex, it started popping off like crazy. The channel's going off. Let me know if there's any LeetCode questions you want me to solve on live. I'm doing a LeetCode grind for a few hours. So my plan today is my plan for today is I need to do a couple things. I need to grind some LeetCode. I need to hit the gym. Like, this is my plan for today. I need to grind some LeetCode, hit the gym. What else do I need to do? I need to set up my coaching. I want to start meeting with subscribers and giving advice that I can give. If there's any advice that I could give people, I want to try to give it. Obviously, like, consult the internet and stuff for more advice, but I think I want to give whatever advice I can give and meet with as many subscribers as I can. So I want to set up some of that coaching, and I won't be charging people for coaching. I'm not gonna, like, I don't need to this YouTube channel for money, honestly. So what do we need to do? So we're counting the plan for today. I just need to write that down for myself. SB, what's up? I'm doing this one question from yesterday. SB, I saw that you saw that Berkeley grad who couldn't land an interview, and I was pretty shocked because their resume was pretty good. But the more I think about it, I think that their standards for where they want to work is really high, and you can't. Ryan, thanks, appreciate it. So that Berkeley grad, I think his standards are really high, and that's fine. It's perfectly fine to have really high standards for yourself, but you can't really control if you're gonna get an interview at a FANG company. Yeah, he was pretty good. He had a really good resume. He structured the resume the way that recruiters always tell me to structure it, and he obviously went to a target school. Berkeley's a target school. He lives in San Francisco, and San Francisco has a lot of jobs, obviously, because of the tech industry. But he said that he couldn't get interviews, but he is in the process for like SpaceX and Bloomberg. So I think his standards are just really high. So most of the advice I was giving him was just like control what you can control, kind of thing. Yeah. Because getting a job at a FANG company, there's a lot of luck involved in it as well. And you might not get it as soon as you graduate, but probably 3 years, 4 years, 5 years down the line, if he keeps it up, or if anyone kind of keeps it up, I'm sure they'll be able to land a FANG company. Just because they couldn't do it right away, I wouldn't like put myself down on it. Yeah. Luis, what's up? Dude, it went crazy last night. I'm just trying to. Let's see how high I can get up today. It's at about 2,104. It went crazy. So I'm gonna solve this question on my main account real quick, and then please give me more questions so that I could solve it. Like, give me more questions to solve on other ones as well. And some subscriber told me that I say like too much, so I'm trying to work on my public speaking and stop saying that, honestly. I don't know how. Yeah, let me know what videos to make and stuff, because I just want to make videos that's going to be helpful to y'all. And I want to make videos. I don't care if the video goes viral. I just want to be able to help the people who are actually subscribed to me and support me. So this other guy named E is asking for advice on like subsets and permutations. So I'm gonna do a video on that. I might do that a video in here. Like, let's see. Let me figure out what topics to cover. I can cover that topic later. So let's do a sliding window with a hash map. So one thing I just learned yesterday is if you go n times n minus 1 over 2, where n is the number of frequencies, you get the number of pairs. So pretend I have an array of 3 ones. So if I go n times n minus 1, that's 6 over 2, we get 3. So that means there's 3 pairs if I have 3 ones. If I have a frequency of 3 ones, and that's correct because you have 1, 2, and 3. Now let's try that with 4. Let's do one with 4. And see if it calculates. That's kind of the trick here for this specific problem. Count number of ones. So we have 4. We had 4 times 3 divided by 2. What is that? 12 equals 6. So we get 6 pairs. That makes sense. 1, 2, 3. Then you go 4, 5, 6. Yeah. Okay. So this if we keep track of the frequencies, we can keep track of the number of pairs, and we could do a sliding window solution here. Yeah, appreciate it. Appreciate it. I appreciate the support. Luis, Paul, SB, Alex, Ryan, Jay, Null, all these people have been supporting for a while. So we'll keep dropping. Please just let me know what you want to see as well. I'm gonna tell E to hop on the stream. Bob, thank you, appreciate it. I'm gonna tell E to hop on the stream later so I can teach him the subsets and permutations. So we count the good subarrays. So let's do count pairs, self, frequency. Could you do a vid? Could you do a vid on how to tell if a job is a ghost job? Are you applying for? I feel that the big companies don't do ghost jobs. What jobs are you applying for, and what forums are you applying on? Are you applying on LinkedIn? I think that LinkedIn also screens all of the different postings and will take down jobs. To pretty much any data jobs on LinkedIn. Paul, have you added? Are you part of the Discord? If you're, hop on the Discord, and then I want to help you figure out the job hunting stuff and learn more about your job hunting. Count. So we're going to do n times n times n minus 1 divided by 2. So we're going to do a sliding window, but we're going to do sort of you're in the lounge? Okay. Let's- Bored, what's up? Okay. Can you hear me?
Yeah, I think so.
What's up? What's up?
All
How
right, sorry, I had to stream. I didn't know if I could like hear you or not.
how's the job hunt?
I mean, it's not going like disgustingly terrible. I have like I've gotten replies from I think two or three companies, like doing me for interviews. I did a phone screen with one HR person from a company called Fathom, and she basically asked me about my experience and stuff, and then I got rejected like 2 days later.
Bro, that's
But
whack.
yeah, I don't know. Maybe they just it's like Fathom Healthcare.
Wait, where are you
Uh,
based?
I'm based in Kentucky right now.
And then where do you want to work? Like, does it matter?
Uh, I mean, preferably remote, but if not remote, probably either like Seattle or Boston or Texas. I don't think I want to live in the Bay Area. I don't think I'd like it very much there.
Yeah, I mean it's not definitely not for everyone. And there's a bunch
Yeah,
of weird stuff going on, but
yeah.
you want to work remote. What's your degree?
Uh, Computer science and engineering.
And you want to work data roles specifically?
I mean, honestly, I don't really have a preference. It's just that all of my experience right now is in data roles. So, except for like, I could probably spin the software engineer thing I did at Equifax. I could spin that off as like not data role. Like, I have knowledge of non-data stuff. It's just most of my experience is data roles. So I feel like it's probably easier for me to get into data roles at this
I
point.
see. Wait, let me look at your resume. Your resume is good.
Yeah, I
Build
don't
up.
know if I'm just like not passing through ATS or what. Like I get rejected a lot and get ghosted like more. I
Okay.
don't know if it's just because I only started applying in like middle of December and my resume until right after Christmas was like pretty bad. I chat GPT to make it a lot better, I think,
Yeah, let me
in
look.
terms of the formatting and stuff. And I like used an act like I didn't it was funny because the resume template I used before had terrible like dates and stuff. Like the dates were just wrong.
Yeah.
So I fixed it all after Christmas. And I don't know if it's just because I've only been applying for like basically 2 weeks of people actually working. And it's also like right after the holidays, so people are, waiting a little bit, or if it's just like backlogged or what. I don't know if that's it,
You're
but
looking for
not
internships
sure.
or full time? Because you
Full
graduate.
time.
Oh, okay. Are you doing the online masters?
Yeah,
Oh,
yeah,
that's
it's
sick.
part time.
Is it hard?
Uh, I mean, I've only done it for one semester. I took a class called algorithms, like GA, graduate algorithms, and I took machine learning for trading.
Oh wow.
Machine learning for trading was like pretty easy. It was just a lot of writing, and GA, in my opinion, was not that hard because I'm good at algorithms, but like there's a bit of an issue where they were accusing a bunch of people of cheating and like sending them to OSI, which is like the office where they, do academic integrity complaints and stuff, and they sent like 300 people to OSI this semester.
That's
So
crazy.
I got a 0 on two homeworks,
No
and
way.
I ended up getting a B in that class, unfortunately.
And they're accusing you of cheating even though y'all weren't even cheating?
Yeah, they were saying everyone was using ChatGPT on the homeworks because it was basically they gave us a problem, and it
Yeah.
was like a divide and conquer problem, right?
Uh.
It was majority element if you're familiar,
Hmm.
but they basically gave us that, and anyone who used a tournament algorithm basically got sent to OSI because they didn't teach it in the class. But it's really weird because most of the people in there have grinded LeetCode, so everyone knows what a tournament algorithm is.
Bro, that's dumb.
Yeah,
So,
but what can you do?
yeah. I think your resume is good. Let's see. Data engineer, contract soft. Why not just put just straight up software engineer here instead of contract?
Technically, I wasn't working like at Equifax. It was through a contracting agency,
I
so I
see.
just don't want them to like think that I was lying when they do a background check.
I see. I see. Okay. Yeah. You should put your projects on here too. If you did anything in school through the projects, and you're did you do a bunch of leadership stuff? It looks like you probably did that during school based on like all the stuff here.
Not really. I did one cool project. It was like a bin packing algorithm in
Nice.
college. I thought it was pretty cool. It was like using a we use like a heuristic in order, it's because bin 3D bin packing is considered NP hard.
Mm.
So we had to like come up with a solution that was better than what human because it was basically humans packing bins manually. So we just had to come up with a solution that was better than that.
Wow, that's crazy. Okay, this is you should add a project section here.
Yeah, I mainly haven't because I just don't have room, but I was thinking I could take off like my tutoring and my because like the student or I could just combine those all into one. Like all of the because all of those are at my school, my bachelor's. Like the state school ones are all at my bachelor's
Yeah.
school. And one of them was like database developer, so I basically like did a contract with them so made a I made a database for them.
Mm.
And then the other two were tutoring and grading calc.
Yeah. Okay.
So I could like combine all those
So
or just remove them.
what are some good projects that you've worked, or just tell me about all the different projects you did, and then let's figure out some to throw in here because you do have space. Look, between these, that's a if you start crunching some of this little space, you'll get a lot of
Well,
for
that's all single space. I don't think I can actually crunch that more.
yeah, I'll show you what do you use to
I just use Google Docs.
yeah, for Google Docs, I'll show you how to do this. Um, cuz I use Google Docs as well, and I'm you can crunch this space, right? Like in between these. If you highlight it, here, let me bring it up on a separate tab.
Okay.
I'll show you one of my resumes and how to format it. Because you kind of need as much content there as possible. Obviously, you
Yeah.
still have a lot of space at the bottom and you don't want it to look too cluttered. Because,
Yeah, that's what I was thinking. I just don't want it to like be unreadable.
yeah, but
I combined that one point on my first experience. I combined that to one line because
nice.
that was just from changing the font that happened.
Okay. Okay, yeah, I remember yours. Like, you switched the font before, and then.
Yeah, I switched from Times to Arial.
Okay, I'll quickly show you how I handle spacing. Mine looks a bit cluttered, but nobody really complained about it. But like here, I'm up. Yours is single space here, and the moment I start doing
Hmm.
that, you'll see I'll start getting into like the one page territory.
Oh, so you do like custom point four.
Yeah, so I custom because this is quite a bit of space, right? It's kind of a waste of space. You can experiment dropping the space here to, and obviously I can make it even smaller, but you want to also make it readable. And I found that zero point 0.4, it depends on your resume, but you can play around with the space to get it smaller than one and reduce some of that white space that you had there to make room for some of the other ones.
Yeah, and if anything, I could remove like the interest thing because the interest thing is kind of just like obviously Chat GPT. No one really
Right.
probably cares about that.
Skills and interests.
I mean,
Oh
not the
yeah, remove
skills,
that
but like
interest.
the interest thing.
I did that. I used to do that, and it never. I used to do that for the first 2 months of my resumes, and then I just saw people like no one ever does that. Even when I look at
Yeah,
resumes at
yeah, no one
work,
really cares about like interests because it's probably just gonna be fake.
did you check out this how to build a resume thing? This is
Yeah, I
literally the
did.
best one that I've seen. So like you're structuring it the right way. They didn't. No one ever has like a section on like you mentioned. So I would remove that. What I would also do, one thing I would try also, and it's all a trial and error. You've only been applying for 2 weeks, and that's I wouldn't expect anything back in in just 2 weeks, honestly.
Yeah,
Especially,
that's what I was thinking. Because like, especially because it's the new year, I feel like it'll probably be like maybe like in February I'll start
yeah.
getting more replies. I'm not like super like stressed yet. I
So
also don't like need to stress that bad because I'm not like unemployed or anything. I'm
yeah,
just like looking for a better role.
I see. So there's this one recruiter who's I was talking to this one recruiter who's recruiting at Citadel, and they're trying to help me build a better resume. And one of the things that they told me, especially if I'm looking for tech roles, is to make the resume more tech focused. So make the bullet points like very technically, like more tech
Uh-huh.
focused, and also add some of the languages and technologies that you did
Yeah,
for
and like
on the bullet
parentheses,
points.
like I see you're doing here.
Because I have this language and technologies. That's just an overview of everything that I learned. But some of the bullet points only include some of those technologies. So, for example, in my new job, I'm doing a bit more Python and Django. So, Python and Django are up here, but then they could see which projects I specifically did in Python and Django. And then they
Yeah,
also,
makes sense.
and then some of the things are like Java. So, they could kind of see all the different projects I did and what languages I used in it. So I could let me send you over a bunch of good resumes because the person sent me like four really good resumes from people who were able to land hedge fund jobs. And that's kind of how I structured
Yeah,
my resume. I'll send that over to you. Just remind me. But
yeah, for sure.
I haven't even looked at the chat in a minute. What are people saying? Let's see.
Uh, yeah, it's like one guy saying to add a templates or add a project section. Yeah,
Yeah, add a project section.
yeah, that makes sense. Yeah, I don't know if I should like all those three experiences at the same place. I feel like I should like combine them somehow, but I feel like it's kind of hard because they're all very different jobs.
Yeah. Honestly, I have more jobs here than this, but you need to figure out what to cut in and cut out. And what you need to cut in and cut out also depends on the role you're applying to.
Hmm.
So if I'm applying for a hedge fund or I'm applying to a FANG or I'm applying to a startup or I'm applying to a machine learning company, I'm swapping in and out certain jobs and projects. So I have a big ass resume that has all of my jobs and then all of my projects. And then based on where I want to apply for, I would like slim it down to one page by removing some work experience and removing some projects. But then all for your
Yeah,
projects also have links to the GitHub so that they could easily see what it is and stuff.
yeah. I mean, a lot of my projects that I've done, like, I haven't like done too many independent projects, really. All
Yeah,
of my projects are like through school and stuff.
yeah, that's perfect though. Me as well. When I
Well, like,
was hiring
I'm not allowed to public the repo for a lot of those
oh,
though.
okay. Yeah. I don't know. I would make sure to have like some project in here, preferably something that's like a full stack project because full stack projects show you can kind of work around the stack. You can work on the front end, the back end, the infrastructure. You kind of understand everything end to end. And that really helps with landing your first job because during your first job, most of the time they're looking for people who are generalists unless you're working for a
Hmm.
very specific unless you're trying to get a job a very specific role. Most of the time generalists usually are the most safe hires. So having projects that shows you can work across the stack are I found really helpful for landing interviews because it also like I was mentioning this before, but pretty much like getting jobs, if you think of jobs as like a funnel, like a sales funnel, but basically a job funnel, you want to increase the top of the funnel. And how you do that is by increasing the surface area of what you know. So that can help you get in the process. So to increase the top of the funnel, definitely have breadth in a lot of your projects. Or yeah, have breadth in a lot of your projects so that probably the ATS might pick you up easier. If that makes sense.
Yeah, that definitely makes sense. I guess that's another reason I was what do you call it? I mean, to be honest, I wasn't like applying for web dev jobs or any of that, like anything with front end, because I don't really like I don't I can do JavaScript, I just don't like it, so I just haven't been applying for those. But I could see how like having that knowledge could be useful for back-end jobs as well.
Yeah, especially if it's a side project, because it really shows that you. Because sometimes I've worked with data people too, and if they only know data, I feel like the most productive ones kind of understand the product as a whole. Because when you're working, for example, when you're working on Equifax and you only know how to like run data science techniques on like the credit data, then you're really just. I feel like the best engineers or best data people understand the product as a whole. So they understand like how the data gets in and everything like that, how data is aggregated, how data is cleansed, all of that. They kind of know the full stack, but obviously they focus in on what they know. I kind of worked in
Hmm.
a data adjacent role or a Equifax adjacent company before, and yeah, our best data scientists knew more than just the data science stuff. They knew how to take the model and deploy the model, and maybe not directly, but just like at a high level, they understood that stuff. So I think highlighting that with like a full stack project, maybe build a project where you take a data, where you take some model that you built and deploy it and build some front end that uses that data model might also be a good project.
Yeah, that definitely makes sense.
Yeah.
Yeah, I could probably try to
But
do
yeah,
that. I
definitely
was thinking,
drop a project section. What else? So say
yeah, I
education
think
techniques.
another thing that will help is like once I graduate from a master's, a lot of like data roles, like especially the data science or ML roles, they want like a master's. So I feel like that'll help as well.
Yeah, for sure. That's you're looking for data engineering roles are harder than regular software engineers, so I could see why you're saying that there's some trouble. Because even when we would hire data science and data engineering roles, they're usually very experienced. So sometimes you may need to just break in. If you go like a year and you can't get a job there, I would break in as like an adjacent role, like a software role, and you could switch in. I've seen people do that. Switch from regular software backend into data roles when after they get into the company. I've seen that happen as well. That's another strategy.
Yeah.
It's like
Right
you
now I'm interviewing with a Series B startup. It's
nice.
like I think they're considered financial services, but I don't really know how exactly fintech in quotes it would be.
What's the
I think they're like
company?
a webs. It's called Amount. Um, but yeah, I think I don't know. I think I might get that one. They seem like
Nice.
they like me, at least the ones I've interviewed with so far.
Yeah, it's all about just breaking in. So this healthcare company, see, you have experience. So I would just say, yeah, your resume. If we just add the sections that we talk about, we can improve it, and then just send it over whenever. So I would just add some more metrics as well because you're saying you boosted accuracy and insights. Do you know by how much? Like, is it
Uh,
quantifiable? So this is quantifiable. This is quantifiable, but some of the other bullet points are less
yeah,
quantifiable.
yeah. I could quantify a couple of those. I mainly like whatever I was like sending you the anonymized one. I didn't have an anonymized one, so I was like in bed, but I got on my computer and I just like anonymized it real quick and sent it over
Yeah,
because it was like 3 a.m. for me.
you're. Oh yeah, because you're in Kentucky. So for
Yeah,
example, I have some where I optimize like ML algorithms. So I increase the accuracy of a object tracking system by 20%, and I say exactly what I had to do that kind of thing. So I think
yeah, that makes
adding
sense.
metrics and results definitely help. But it's all a
Yeah,
numbers game at the end of the day. I honestly don't know even if my resume is good, but I've able to land interviews and stuff, so it's probably like
yeah.
decent.
I mean, I'm hoping like if I get that one job, it's in like the financial space, so I'm hoping it'll be easier for me to get into like better companies after being at a financial company because it has like people who have worked at good companies and there are people who like went to really good schools there. So I feel like it's probably not a bad company. And it's
Yeah.
invested by Goldman Sachs,
Oh
so
wow.
it's not like a nothing burger company or anything, I don't think.
Yeah, uh, it's hard to just break into the exact company you want to right away. You should definitely
Yeah,
think of your
especially if you don't
career in
go to a
like,
target school.
yeah, exactly. You need to think of it in steps as well. Like the
Yeah, that's what I'm doing. I'm just thinking like hopefully I can get into like something that's at least adjacent to the field I want to be in, and then I can hopefully like it'll be easier for me to break in than from a healthcare company.
exactly. No, that makes a lot of sense. Because I think the other guy yesterday, he really just wants to break in Fang right away, and you can't really control that. If I if I was him, if I didn't get in Fang, I would just figure out ways to set myself up to get in Fang. But I wouldn't
Yeah.
like beat myself up if I can't get that right away. So I think what your mindset here is more balanced, and I think that it's a good idea.
Yeah, I don't even know if I'd want to be in Fang just because of like the story. Like, I think I'd rather be in more of a fintech company or like maybe a quant role if I ever got cracked enough to do that. But like, I don't. I'm definitely. I don't think I'm cracked enough to be in a quant role right now because I'm like my C++ is definitely really rusty.
You could do
But
a lot of jobs are hiring Python a lot more. When like quants would hit me up, they I would just tell them I only know Python. They'll be like, okay, it's okay. And I had a friend doing Jane Street
mm,
and other like Citadel, Jane Street, and some others. They let you interview in Python, and there's Python roles in those companies.
yeah, I know. I've like looked into the bigger companies. All of their Python roles, they want a PhD and they want it
Oh,
from like a top five school.
that's
Because
crazy.
they're like they just pay so much money that they just have all of the insanely correct candidates applying for them.
Yeah.
Like all of the MIT kids, they're all applying to those companies. So they just have a litter of choices. So they're just not gonna pick someone from like a no-name state school.
Yeah.
Realistically, it's just not even gonna go through their ATS. They're just gonna like deny you.
No, it's crazy too because I've worked with like people from those schools, and sometimes it's hard to even you forget that they even work at this or even came from those schools. I'm pretty sure you might think that you're not as good as some of these people, but you never know. You might actually be, and they might not even be that much better than you. Because I've worked with people from those
No,
schools all the
I,
time, especially
I've
in the Bay Area. Or go ahead.
definitely met a lot of them. I've met a lot of them, and I think better at coding.
Like you can see that they're different. Shoot, I think this cut out. One sec. One sec. Hold up, my Wi-Fi got bad. I'm back. Can you hear me?
You bet.
Yeah,
Yeah,
dude. What SF Wi-Fi
I can hear you now.
sucks. It just randomly cuts out. You can hear me? Wait one sec. How's it doing
Yeah,
now?
I can see. I'm surprised by that because don't you guys have fiber?
Yeah, I'm gonna fix. Dude, I pay like $100 a month too, for my Wi-Fi. It's crazy,
Don't you guys have fiber there?
bro. I have no idea. Maybe there's just so much. Like they're not managing the grid properly or something.
Yeah, I mean, I think infrastructure in a lot of like huge cities is usually pretty bad.
Yeah. How
But
many
yeah,
LeetCode
definitely.
questions
I
have
don't
you
think
done?
like a lot of. I mean, obviously, I think how many elite codes?
Yeah. Are you good at LeetCode?
Probably like 250.
Wow, that's actually good.
I'm good enough at LeetCode to pass a technical,
So yeah,
unless
you're
they
good,
ask me
man.
like two hards.
You're good. No, a lot of the people who've been joining the channel have actually been good. Like, are actually really good, which is sick. Like, people on the chat are usually good
Yeah.
these days. It's crazy.
I don't think we've had. I don't think we've had any like people who are like insanely cracked, but like I think most people who have like joined or talked are like usually pretty good.
But it's all relative to like you might not say you're cracked, but I know people who say that it takes them like a week to do one LeetCode question, and they've only done like 50 LeetCode questions. So if you did 250, you're
Yeah,
already probably like
usually
the top like 2% of LeetCoders or something like that.
I'm gonna be honest. I hadn't leak coded since like 2022 until like 2 weeks ago, whenever I was getting that one interview. and I thought they were. It was like a technical, right?
Yeah.
And I thought it was going to be really LeetCode intensive. So I like grinded LeetCode all weekend, and I did like the neat code, or I did the LeetCode 150 for interviews or whatever over the weekend.
Yeah.
And and then I like after that they didn't even do a LeetCode. It was like design a list to simulate a village, and I was like,
Oh.
oh,
Yeah. I only get asked lead code questions when it's fan companies, and a lot of startups just straight up ask me non lead code questions, like coding questions that are also really hard, but they're not lead code questions. So I only really
yeah,
prepare lead code questions if I have a FANG interview or like a FANG adjacent or super big company where I know they're gonna ask me lead code question. But lead code still helps you learn how to code. But yeah, not every job. I would say like 80% of jobs won't ask you just straight lead code question. Shit, I cut out again, bro.
yeah. Are you able to hear me?
Yeah, I can hear
Yeah.
you, but my thing's annoying. Okay, I'm gonna grind back on this lead code question. Yo, send me some more
Uh,
lead code questions to
I
do.
can't hear you.
Oh,
I'm like watching your stream. I think it might be something messed
I
up
can
with your
hear.
mic on
Wait, let me
Discord or
see.
something.
Let me hop back in. Can you hear me again? Can you hear me again?
Yeah.
Yeah. Okay. Let me see. Yeah. Let me know if you can fix up that resume and just send it over. And then if you need a referral or anything, just hit me up. You already have my info.
Yeah, for sure. Thank you.
No problem. All right.
Uh, yeah, I think like the one thing is just I don't know, getting into the out of the healthcare space will probably be really helpful in my opinion. So I'm just trying to get that. Also, I think a reason I want to work remote is because like all of the big companies in big cities for the roles that I could like realistically apply to and get, they're paying maybe like 100K,
Yeah.
and 100K in San Francisco is like 30, 50, 30, 40K where I live now.
Yeah.
So it's like it's hard for me to think about doing that at the moment.
With your experience though, you could probably get way more than that in San Francisco. My first job was much more than that, and it was like at a lower. It wasn't really even
Hmm.
a fan company.
Yeah, I've been like mainly the San Francisco roles like on site that I've looked at have been Fang. So I feel like Fang they started to pay lower than like startups because startups like obviously Fang has way more name value, so people are just gonna apply to it even if they don't pay the super big bucks anymore.
Yeah, startups will definitely pay you the most. I feel like if you break into San Francisco for like 1 or 2 years, you can also get good experience and just dip. You can go Seattle, wherever. It's kind of maybe just
Yeah.
like put in like a year or two, get that experience. Earlier in your career, working on site is sometimes better as well, because then you just could just ask questions right away to people. So
Yeah,
I
for
don't know. That's
sure.
also an option, and then eventually a lot of times too what I've seen people do is they break into San Francisco startup. They make a name for themselves, and it's not that hard to make yourself really like make a name for yourself in the company and make them like want you to stay. You just have to kind of put in, even if you just put in like 8 hours each day of solid work, they're gonna want to keep you. And after, just move somewhere and they'll just pay you
Hmm.
remote. A lot of these startups, to stay competitive, they won't decrease your pay if you like change locations because they want to stay competitive. A lot of the companies that I saw, they'll pay employees the same no matter what state they're in. So that's also another option. I've seen people do that.
Yeah, that's good to know.
Yeah, and you're already a US citizen and stuff like that, right?
Yeah, I was born in the US.
Nice.
That's not I feel like that makes it a lot easier for
Yeah.
me.
So, I don't know. I think it's like if you spent a bit of time in San Francisco like a year or two, that would be good for your career.
Yeah.
And the rent prices have not dramatically increased. They actually stayed the same while wages have went up. So people are making good money out here. I pay 16.50
Mm.
in rent, so I don't even pay that
Really?
much in rent. Yeah,
For like a what? Like a studio or a one
studio like
bedroom apartment or what?
300 square feet apartment. It's a studio, but I don't spend that much time in. It's a
Yeah.
I live like right in the middle of the city, so I just like leave my house and like hit the gym, like random stuff. I'm pretty much always out. I pretty much just sleep here. So
Yeah.
I
Yeah. That's
yeah.
it's funny that because like where I live, like I have a 3 bedroom house and it's only 1,400.
Holy crap. No,
Yeah,
like
and it has like a big yard and stuff.
no, honestly, that's like a and you have family and stuff there, right?
Yeah, like I live with my girlfriend and I have dogs.
Gee, okay, yeah, that's way harder to leave then. You have a bunch of stuff there.
Yeah.
So yeah, honestly, yeah, then I wouldn't recommend going to SF. But definitely look up try to get into look at like the different Y Combinator companies and maybe one of those will hire you remote because they're always just looking for people.
Hmm.
Did you
Yeah, I'll look
see
into
did you
those.
see my video on like how I got into Silicon Valley kind of thing?
Yeah, actually, I think I watched that and then I saw you were live and I was like, oh, that's neat. And I started
Nice.
watching you.
So I think where is it? How I made so this one the strategy of how I got into Silicon Valley, you can kind of apply that not even just breaking Silicon Valley, but just in breaking the job industry in general, like finding fellowship programs or finding people who have connections, people who can hook you up with like a bunch of interviews at once, like get a bunch at once. That's usually the most helpful part instead of applying one by one. But I think you just started applying, so I wouldn't sweat it yet. If it goes to 2 months, three
Yeah.
months without ever getting a reply or interview, then just let me know, and that's like a different story for a different day.
Yeah, yeah, I'm not really sweating it yet. Just like just curious.
Yeah, cool, man. Thanks for hopping on. That was a good chat, and just
Thank you, man.
message me.
Yeah, I'll update a few of those bullets and
Sounds
add a
good.
project section.
All right, cool. Let me know. I'm gonna get back to
All right,
this leak
thank you.
code question.
Yeah.
All
All
right,
right, thanks.
no problem.
Bye.
See ya. What's up? I'm gonna cover what you were talking about before, which was you wanted to figure out subsets and permutations, right? Let's see. And heap from scratch. You wanted heap from scratch. What are the topics you want me to cover? We can implement a heap from scratch together. Paul, no problem. Anytime. Just message me whenever and we just hop on. Yeah, yeah, yeah. That's actually the best way. I really like that permutations way. Let me bring the chat here. I really like the permutations way of doing it. And I was gonna suggest that initially. I actually had a video where I suggested that, but I didn't post it. But I think you still need to know. Yo, heaps from scratch is very simple. I'll break it down. I'll break it down for you. So let's cover that. It's actually more simple than you think. So we'll cover subsets and permutations. We'll cover subsets and permutations using. We'll cover subsets and permutations using BFS and backtracking. But I think you definitely should learn it using backtracking first, and then the BFS one is just kind of like a nice little way to do it. But the backtracking one, some companies might expect you to do it backtracking. So let me figure out this question at first. Okay, E. Okay, let me just do the subset one. Let me just explain the subset one real quick, actually. The first thing to know is backtracking is pretty much boilerplate. When you define a backtrack, yo mod, what's up, Caesar? So backtracking is very boilerplate. You pretty much just like try solution, recurse, so you're gonna have a base case, you're gonna try a solution, recurse, and then backtrack. Most of the time you're gonna have like options and a path. This is kind of boilerplate backtracking algorithm. And I'll show you how to generate subsets using that. So pretty much when we start here, our options is like 1, 2, and 3. Yeah. Dude, the same. I'll show you my Sudoku solver boilerplate after as well. And it's all just send me you can use the same boilerplate to handle subsets, permutations, everything backtracking related. Send me backtracking ones and I'll literally just copy and paste that algorithm, make a slight adjustment, and it's gonna work. But it's pretty much this. You have a base case, you try a solution, you recurse, and you backtrack. And then let's figure out how to fill this in. So when we first start, we have our options here. And how I would look at it is it's pretty much a tree. So when we start, these are our options. Honestly, even dynamic programming is boilerplate for top down. But essentially what we do is when we have options, we start with the first option, and then as I mentioned here, we have to like try a solution and backtrack. So we have two choices here. In the first level of recursion, we have two choices. Pretend we have empty here. Or we start, this is the root. This is the start, this is the root of the recursion. These are our options. We have the option to choose 1, 2, or 3. We're gonna start with 1. We have the option to choose 1 or choose 2. Or we have the option to choose 1 or not choose 1. If we choose 1, we go to this path. If we don't choose 1, we go to this path. So that's us trying the solution. So we essentially try the solution, and then we recurse. Say we try 1, then we recurse, and our options move forward because we already tried 1. Right? Let's say this is empty. And let's follow this path. Now we have these options. We've already tried 1. Now we have the option to choose 2 or not choose 2. We can choose 2 or not choose 2. 1, 2, 3. Now we're in this level. We have an option. We already chose to choose 2 or not choose 2. When we're at this level, yeah, bro, it went crazy last night. Or last night my subscriber count went nuts. Or pretty much this morning. But I'm trying to get it to 3K today. Let's do that. So now we have option 3, right? So pretty much we have the option to choose 3 or not choose 3. 3 or not choose 3. Right? And the base case is when we run out of options. And pretty much the reason why we backtrack pretty much means we just pop it out of the path. So backtrack means, okay, we explored this path, we chose 3 and we added it to the path. When we like backtrack this way, right? We need to pop 3 out of the path. So let me just like implement that. Does that make sense so far? E, you got any questions? And one sec, let me quickly close the window, and then I'll implement this, and I'll show how this same boilerplate pretty much works for every backtracking algorithm. And then I could even probably show like dynamic programming and how you could usually backtracking is essentially brute forcing, and then you can modify backtracking or brute force algorithms to solve dynamic programming questions as well. So let's just implement this quick. Let me close my window because it's super sunny out. The weather in San Francisco this week is crazy. The weather is like 17 degrees, all sunny every single day for the next 2 weeks. Give me a sec. I'm gonna close the window. Okay, let's implement this algorithm that I mentioned. So we have our options, right? Our option is pretty much numbers. And then we'll have like our index. So index is basically this arrow that I have right here, which tells us like what options we have left. So pretty much our base case is if the index is greater than or equal to the length of options. That means we're out of options. That's the base case. We need to return, right? And then we'll have a result here. We're gonna also maintain the path. We also need to maintain a path, so we keep track of where we've path. Usually, in a lot of backtracking algorithms, you're gonna maintain the path or some sort of data structure that keeps track of which path in the tree you're in. So I just call that path, and what I'm gonna say is if the index is greater than or equal to the length of options, that means we have no options left. We're gonna save the path into the result. So I'm gonna say result.append, and I'm gonna say for elem in path. That just like creates a deep copy of our path, and we add it to the result. That means we like hit the bottom here. That's the base case. And then we can try the solution. So we can try the solution with self.backtrack. We can try the solution. So let's say to try the solution, do path.append options at the specific index. So for example, we're gonna choose this path. So we're gonna add 1 to our path. So that means we're exploring this way first. So we say path.append options at index, and let me know if at any point none of this is making sense, and I can clarify it. So we add the first 1 to the path, and then we backtrack, and then we have to pop it out the path after we tried it so that we can go and explore this right side. So we do self.append options at index, and then we're gonna go options index plus 1, and we're gonna pass in our path, we're gonna pass in our result. We say path.pop. So we're gonna try solution, and then we're going to try that solution, and then we're gonna backtrack as well. So that's us trying 1. And then also what we can do is in this Try element. We have two options here. We can try element or don't try element. So you could see that in this path, if we just look at the first level, let me remove this. So the first path here, we are at the root. We try one, and that will recurse all the way down until the base case. And then afterwards, we need to pop one out of the path that we started because we want to try the path. Yeah, we're just moving the index because we just want to try nothing. So we can try element or don't try element. And we only need to backtrack if we tried the element. So something like this. These are the two options. We can try element, and note we only need to backtrack. Track when we try the element. So now let's just run result. Return. Now we just say nums index is at 0. Something like that. Let's just hopefully the thought process there makes sense. Let's see if it runs. What happened here? Print. Oh, I need to just return 0 here. What's going on? Print. Path.append options. Let's see what's happening here. Print path. Oh yeah, you're right. There you go. So in pretty much in like 12 lines, we solved that. Does that make sense? And let's do permutations next. And then let's work through implementing a heap. Yeah, backtracking is basically boilerplate, honestly. Let's hop into the questions. Let's do permutations. Noor, were you here from the start? I'll explain permutations. Noor, did that make sense after the explanation, or my explanation didn't make sense there? So we're gonna do a backtracking algorithm here again. What we're gonna say is like, as we said before, we have a base case. I'll put the chat over here. The chat's a little bit slow. The latency is a little bit slow. Okay, what I'm gonna do, Noor, is I'm gonna clip that piece of the video, and then I'm gonna post it, and we could explain and then you could watch that one. I'll send it over. But let me work through the permutations quick, and I think you'll understand after I show how to do the permutations. It's the same kind of algorithm, it's the same backtracking algorithm. Okay, what we're gonna do, I think we need to do a more basic, like the backtracking algorithm is like we have a base case, we try something, we recurse, and then we backtrack. That's why it's called backtracking, because you want to try a path and then you want to backtrack. So you want to pretend this is and this is getting a bit messy. Pretend this is our tree of recursive execution. pretty much what backtracking is doing is it's trying to go down a certain path, and if it can, and once it gets to a base case or something, it backtracks. It goes back in the tree. Sorry. It goes back into the tree and then explores another path. And the reason, and in order to like actually backtrack, you need to pop the elements that you explored in that specific path off of the path. So let's just work through these permutations. So you have 1, 2, 3. So let's work through this question. It says, given an array of integers, return all possible permutations. You can return the answer in any order. So like I said before, these backtrackings are pretty boilerplate. So what you're going to do is you're going to be given options. So these are the options of what's available to you to choose in that specific node in the recursive tree. So we're going to be options. We're going to be given like a index. So essentially, let's just start with 1 right here. And let me just like draw this out from the start. And that might help everyone out. So let's say again, this is the options. Right? And we start the index at this element. Pretty much what we're going to do is like we're going to start our recursive tree, and we're given these options. So since we're trying to generate all the different permutations, we want to try different elements, and then we essentially want to do a backtracking brute force solution to generate all the possible permutations. So pretend these are my options. So the first option, I'm going to choose like 1 here. That's one option. I can choose 1. The other option, this one's a little different because the other option, I'll choose 2. Because we want to generate, basically what we're trying to do is figure out what should be the first element in this array. So I can choose either 1, I could choose either 2, or I could choose either 3. Right? After I choose 1, 2, or 3, and what's the limit here? No, it's I. Dude, it's loud out here. There's like sirens and stuff. So now pretend I chose 1 as this element. We're gonna explore this area of the tree. What are my options? My options left is like 2 and 3. So here I'm gonna try 2, and I'm gonna try 3. Right? That's my options. If I pretend I continue exploring this path, what are my options? My options is pretty much 3 left. So I get this. Pretend and then pretty much that will get us down here. So the base case is if we don't really have an index here, it's a slight difference, but the algorithm is pretty much going to be the same. Where we have options, we're going to have our path, and we're going to have our result. And our base case, we need to figure out the base case, and we're going to say if the length of the path is equal to the length of options, that means we chose, because all of the options, all of the final results in the output need to contain all of the numbers in nums, but in a different permutation. So we'll say the base case is if the length of path equals the length of options, we're going to return. So I'm just showing how like you could just fill in this boilerplate backtracking. You just need to know that base case, try something, recurse, and backtrack. So we're going to be for options in path. What we're going to do is we're also going to give a scene array. Scene is going to let us know which options we've already seen, but essentially, okay, when we get to a path, what we're going to do is we're going to result.append, and we're going to copy for lm in path. We're going to do a deep copy of the current path and then return. So what here we're going to try something. We're going to loop through for why not length Yeah, essentially that's what's happening here. I'm gonna convert options basically when I call back. Let me fill this part in then. Do Tom, what's up? Yeah. We're past nums. Path is empty. Scene we'll use a set, and then result we'll pass this. So nums the parameter becomes this, and then we'll return result. So we'll say for option and options, if option is in scene, we continue. Tom, what's up, man? Thanks for subbing. So what we're gonna do is we said we're gonna try something, recurse, and then backtrack. Right? So what we're gonna do is we're gonna try, like, for each option, we only want to try. What's like I just lagged. I'll cut in and out from time to time because the Wi-Fi here in SF is just terrible. I think like every hour it's cutting in. Like, everything good now? Yeah, okay. Looks like everything's good. So we want to try something. So we're looking for options that aren't in scene. So if it's in scene, we continue. Otherwise, we do scene.add option. So we're gonna try something, and to recurse here, we're gonna do scene.remove. That's the backtracking part. And then we're just gonna recurse here. We're just literally filling out this boilerplate. And then send me more backtracking algorithms, and I'll show how it works. Recurse, backtrack, and then we'll do self. You get options. The path. Scene. Result. What happened here? Result. We pass in nums. Let's see what we get here. Path. Oh, we're not adding to path. Path dot append. So we're trying something, so we're adding it to the path, and then we're removing it. Do you see how that, like, you can literally just run the boilerplate code there to fill out any backtracking algorithm? You just need to figure out like how the options are gonna work and the path is gonna work, but essentially that's what you're doing. Let me know if that all made sense. Just ask questions if that didn't. So the reason we chose a set here is because pretty much, let's look at it. It's pretty much how we're handling the options here. Like, pretend in this first level we chose option 2 instead of option 1, because the way that this question is working is we're trying to figure out, and let me pop open the chat to the left. I need to get my Wi-Fi working more optimally because this is annoying. Okay. Essentially what's happening is in the permutations question, in the first level of the recursion, we need to pick we're trying to fill out the permutation, which is going to be like this, right? Yeah, we're skipping the items in the set. Because, for example, we have permutations. We're trying to generate all permutations that are size 3 with these options, right? So in the first one, we can choose 1, we can choose 2, we can choose 3. That's kind of what I'm figuring out here, like what to put in the very first element. You can see this is like the 0th index. This level is the 1th index. And this level is the 2nd index. So if I chose 2 here, in this part, if I'm analyzing this node, I have to skip over 2 I need to look at either 1 or either look at 3 when I'm trying to figure out what to place next here. So it's basically trying to figure out what options to choose here. If I already chose 3, I need to either choose either 1 or 2. And using a set here allows me to do that. So it basically skips over the option. It lets me know what options I have left here. So it's a slight variation of what we had to do before. But yeah, let me, or Jay, or who's asking? Noor, let me pop open like a easier backtracking question, because that, I think that will explain why we have to try something recursive and then backtrack. Let's look up. Or Noor, let me show you. Let me show you why exactly you need to try something in recurse. Pretend we're in a maze, right? Pretend we're in a maze. Let me generate my own LeetCode question here. Pretend we're in a maze and we need to return the path to the exit. Right. Pat, we're working on learning backtracking. So pretend we're in a maze and we need to return the path to the exit. And the exit is somewhere here. Say the exit's here. Pretend there's like multiple paths we can go. Noor, this is like a very classic backtracking. This is a very classic backtracking algorithm. Say pretend we're in a maze and we need to return the path to the exit. Yeah, yo. Oh, yeah, Rock dude, I was just at 1K earlier this morning. The channel's really going nuts. But I appreciate everyone supporting the channel. And just let me know if there's anything that I could do to help y'all. Because we're gonna take this channel up and up and up. We're gonna take everyone here to the top. Appreciate it. W's in the chat. Noor, are you still here? Okay. Liam, hey, he's in the building. Okay, I'm quickly explaining the backtracking algorithm because somebody explain why you try something in recurse. Explain why you try something in recurse. The reason why you try something is pretend I'm in a maze and I need to return the path to the exit. Pretend I need to return the whole coordinates for me to exit. If I'm here, I don't know where the exit is, so I kind of need to just try one path, and if I hit a dead end, I need to go backwards. So pretend I'm storing a path, and let's just say these are the different points in the path. There's 1, 2, 3, 4, 5. Or let me put different numbers. So this is just like backtracking explained simply. So pretend we're in a maze and we need to return the path to the exit. And let's label like the different steps within the path. Nine. This should be a LeetCode question. Dude. So pretend these are the different points in the path, and I labeled each road. I labeled each road with a number. So we need to return the path to the exit, and the path to the exit is pretty much 11, 14, 17, and 18. This is what we need to pretty much return, path. So that's our expected. Shoot, my dad's calling me. So this is our expected result. And let's just like maintain a path here. Yeah, BFS will work, but I'm just trying to show how backtracking works, because essentially backtracking is how you can explore all the different paths, essentially. Because somebody asked the question, can you explain why you try something and then recurse? So pretty much, pretend I'm in the middle of a path and I just need to figure out my exit. And backtracking, actually BFS won't work as well because it's going to use up way too much space. Because you're going to pretty much explore all paths at once, and then your array of paths is just going to be massive. So this one is more efficient because pretend I'm in the middle of a maze. I don't know where the exit is, so I'm just going to choose a random path. Let's say I'll mark it with blue. So I'm gonna just try going left first. I'm gonna go left, so I'm gonna add 1 to the path here. And then pretend I just explored this path. Like I just explored this path. I just try that path, and as I explore the path, I keep track of all of my indexes that I visited, or all the roads that I visited. And then here I realized that I'm at a dead end. So now I tried it. I tried something, and now I need to reverse my direction. So I go 4 and 3. I'm pretty much reversing this direction. And as I reverse the direction, I'm popping elements out of my path, because I'm basically saying I visited that road, but when I'm backtracking, I'm popping those out of my path. So now we get back to here, and then we need to explore 5 here. We need to explore 5 here. So you can see, to explore 5 here, I only have 1 and 2 in my path, and I'm going to explore 5. So I add here. 5 leads to a dead end, so I need to backtrack again. So I removed that out of here. There's not really a need to do that. It depends on the, it depends on the problem. It depends on the problem. I would say it actually depends on the problem, if you need to do that or not. If there's cycles in the graph, if there's cycles in the maze, yeah, you'll need to do that. But since it's a tree, you don't really have to do that. You only really need to worry about a scene array if you're working with graphs. Because you only need to worry if there's cycles. So pretend there's a cycle here. If you don't add a scene array, you're literally going to just loop over here over and over again. So you see why I backtracked. I got to 1 and 2. Pretend I already explored this path. Now we need to backtrack all the way back to where I started. So pretend we're back. We figured out that this path all didn't make sense or didn't lead to anywhere. So now I backtrack here. So as I backtrack, I'm popping elements out of my stack, out of my path, until I literally get to empty when I'm back here. And then pretend I go explore. I'm going to explore the next path after. I'm going to explore this path. Or it was blue. So pretty much as I explore roads, I'm keeping track of where I went. So like if I get to the answer, I know the exact paths. I'm essentially just tracking my roads. But you could see why that the algorithm now is pretty much like backtrack boilerplate is you got a base case. So for this case, our base case is pretty much if you reached a dead end or exit, then you need to backtrack. Otherwise, you like try a path. try a road, recurse, and then pop exit it or backtrack. In Codex, I'm pretty much just showing how to implement backtracking algorithm and the boilerplate to implementing backtracking algorithms. Because someone was asking, can you explain the try something and then recurse, like why we have to do that? So I built this very basic question of, pretend we're in a maze and we need to return the path to the exit. And then I was just showing how backtracking can be used to solve that. Did that make sense, Noor, now? The solution of like how we do backtracking? And I'll do like another basic backtracking algorithm just to hammer it in. Let me give like a classic backtracking algorithm from like Blind 75. Let me do LeetCode tag backtracking. Let's look for a good one. This is the classic. We need an easier one. What's this? Pat sum 2. Oh no, there's this other good question that I mentioned that I know of. So this is a good like backtracking algorithm to practice on. And you should try it out too. Yo, Pat, you love that question, huh? I could do that question if you want. Why do you like that question so much? So let's do this question, Noor, just to like hammer in the backtracking solution. Or this one, you don't really need backtracking. Let's see. Yeah, I do. Harry, I do work in the industry. Find all valid combination k numbers that sum up to n such that the following. So here we're gonna do a backtracking algorithm here. So we need to find all combinations of k numbers such that the following conditions are true. Only numbers 1 to n are used. Each number is used at most once. Return a list of all possible valid combinations. So I'll let y'all sit with this question for like 2 seconds while I grab some water. Try to figure out how try to reason about this question before I explain it. This is like, and just know that the solution here is backtracking. So think about this question. Think about this question and then for 10 minutes and figure out how you're going to solve it, and then I'll explain it. Be right back. Grabbing water. Yo, it's my Wi-Fi, bro. I need to figure it out. For some reason, the Wi-Fi out here in SF literally just cuts out and cuts in. But how's everyone thinking about this question? Check. Wait. Check. Check. Okay, it's back. It's back. Bro, what the heck is going on? We're back. We're back. It literally kicked everyone off my stream too. It's nuts. I think what's happening is, yeah, I need to figure out. I'm gonna get Google Fiber and fix this up. This is actually so annoying, dude. Should I connect Ethernet? Maybe I need to connect Ethernet, and then it'll never go down. Everyone back in the chat? Yo, Paul. Okay, try to figure out. Yeah. Maybe it's the Ethernet. Bro, this is so annoying. I'm gonna figure this out tonight. Okay, I'm gonna let y'all figure out this question for like 2 seconds and let me know what you think. Let me quickly look at my Ethernet. Do I have an Ethernet connection here? Dude, how do I connect Mac to Ethernet? I'll figure that out later. Yeah, this thing is so annoying. Wait, let me fix that background is tweaking out. Let me a sec. Yo, if I put a fan on, can people hear my fan in the background? Dude, it's hot here. What do you mean 2 seconds? Okay, let's do someone give me a harder question. I think we already solved backtracking and we already figured out like what to do there. Someone give me a question that maybe you've never seen before and you want to learn on the spot, and we could figure it out together. Okay, Noor, let's finish this one. So we find all valid combinations of k such that so that they sum up to n. And we could only use each number is used once. So what we're going to do is so do people hear my background noise? It's a little bit noisy because I turned on my fan. Does everyone hear the fan, or it's good? Audio's still good. Can reduce this. Okay. So find all valid combinations of k such that they sum up to n. So we're gonna do a backtracking. And like I said before, we're gonna linked list hard. There's LeetCode hard linked list questions? That's crazy. Like LRU, like what, LFU or LRU? I can do that question. I don't know if I... Let me look at that question. Are you familiar with heaps? I can handle that question after. So base case. So base case is... We're going to figure out our base case. We're going to like... Let me reduce this. Try element recurse and go back. We can try element recurse and go back. So that's our base case. We're gonna be given options. We're gonna result. So we're trying to output that, and this is just boilerplate code from the other solutions as well. Oh yeah, Paul, try using a heap. So try using a heap. No. Oh, that one's way harder. I don't know. What's the most optimal solution? I usually use a heap for that, where I store a heap where all the like the value of each node is basically I store a heap of all the different pointers to all the different lists. So I figure out basically the next one to pick. Yeah, exactly. And you have that for every list, and then you just pop it out. Yeah, exactly. And then you just like move forward the pointer and then pop it back into the list. I don't know if that's the most optimal. I think the divide and conquer one is optimal as well, but I like to use a heap for that question. Turn off my fan. Bro, it's so funny. Somebody in my comments was trying to accuse me of cheating because I'm like, he's saying that I was looking in like other screens. I was like, bro, trust me, I don't need to cheat, man. Why would I cheat myself on the... Like, that's just funny. I see. Yeah, that makes sense. So what we're going to do is we're going to be given options. Index, path, and result. So the base case is pretty much going to be path. Just that the sum is up. Find all such that the sum to n only each number. So we need to find all the equal to 7. So we'll store like an extra path sum. So if the path sum is greater than or equal to, if the path sum is equal to we're also gonna get a target. So if the path sum is equal to target, we return. But what we're gonna do is we're gonna say in our result, we're gonna say result dot append, and we're gonna do the same thing where we're copying the path for element in path. We're gonna store all the options that we chose there, and essentially what we're going to do is we're gonna go for result dot append for element in the path. We're gonna store that. We're gonna store the result if it equals to the target. If the path, let's say greater than or equal to. So we'll say if the path sum is actually equal to the target, we do that. Otherwise we need to just return. So we're saying we're gonna try an element and we're gonna recurse. What we're going to do is we're gonna loop through all for I in range index, because we're trying all the different options here. For I in the length of the different options, we're gonna try that element. And what we're gonna do is we're gonna try element, recurse, and then backtrack. So to try that element, what we're gonna do is similar. We're gonna take the path and we're gonna append. We're gonna append options. So we're gonna try that. We're gonna try 1, and if that doesn't work, we're gonna path.pop. And then what we're going to do is the target's gonna stay the same, but what we're gonna do is we're gonna backtrack here. Self.backtrack. We're gonna be given our same options. We're gonna do index is I plus 1 because we already just chose I. We're gonna be given the path is gonna stay the same. The path sum is gonna be path sum plus the option that we chose. Then target's gonna stay the same and result is gonna stay the same. So we just kind of use the boilerplate here, and we have options. We start at index 0. This is the path. We start the path sum at 0. The target is k. Oh no, we need valid combination of k numbers. Okay, we need to we also need to keep track of k, so that we don't go over that. So we need to say k. So we need to pass down k, n, and then result here. So we have our options. We start the options at, options is going to pretty much be like so options, let's say options is equal to this. Because we're saying our options is going to be only numbers 1 through 9. So that's how I'm going to create my options for I in range 1 to 10. That'll give me 1 through 9. So I'm given the options here. I'm given my index. I'm given the path. The path sum equals 0 at the start, k and n. So if the path sum is greater than equal to target, or the length of the path is equal to k. So when we go over what we're looking for, if the path already goes over the target, or we already put too many elements in the path, or the length of the path is equal to k, we're gonna return. I think that path sum or length of path equals k. And if this doesn't work, I'll debug it on the thing. Target. Okay, that didn't work. What do we get here? Output 1, 2, 3, 4. 1, 6. That equals 7. Oh, it needs to be exactly k? Oh, it needs to be exactly k numbers. Okay. Now we just need to modify this slightly. We need to loop exactly k times. So we pretty much just like modified the backtracking algorithm to make it work, and you just, I guess it's slightly different, but the cases are always the same right there. Did that make sense, Noor? I think we just need some more practice with it, but you just saw that I just pretty much modified the same algorithm, and I just know different ways to like change it in order to make it work, if that makes sense. So we still have like the options, and then you just pass in different parameters, but the things that stay the same is the options, the path, target, and result, and you just pass that in. Like you're trying elements, you're recursing, and then you're backtracking. Because here let's try to draw out the recursive tree. Or I mean, if it already makes sense, we can move on. Someone give me throw me a different question. And if you want me to explain it deeper, maybe we can do that. But what other concepts you want to learn? Is E still in here? Y'all want to talk about heaps? Who knows how to implement a heap from scratch? Dude, Donald Trump, honestly, like, I want to ban it too, but sometimes you need to play the game and do LeetCode in order to actually get a job, but it can be annoying. I've interviewed great candidates that just weren't good at LeetCode, but I couldn't even like move them forward because they needed to pass the LeetCode exam. Paul, do you remember? Okay, let's implement one. Let's implement one from scratch. Is E still in here? I'm gonna message this guy real quick. Yeah, let's implement a heap from scratch. If no one knows how to do it, this is gonna be a very useful video. Cause if he's not here, we can try a different one too. Yeah, honestly, building out APIs is good. Like, I don't know. If someone told me that they don't want to ask LeetCode questions to hire people, that makes sense to me. But like sometimes you just have to play the game, honestly. Like if they're like, you need to be able to reverse this linked list for $400,000, I'm gonna be reversing that linked list like 6 times a day so I can get that job. That's just like my philosophy. Okay, what questions? What do you all want to see? Let me know. Let me know what questions you want me to do. Like what questions you struggle with, and let's work through it. Dude, I need to figure out this Wi-Fi issue. I need to figure out this Wi-Fi stuff. It's so annoying. Trapping rainwater too. Let me try it. Let me try that question. But thanks for everyone for staying on even with the tweaking Wi-Fi. It's gonna be fixed soon. I'll probably like clock out in like an hour or two and figure out how to fix that up. So what's it called? Nah, make SF Wi-Fi great again, bro. Okay, that's smart. Donald, I'm gonna do that. So what question y'all want me to do? I'm gonna try, let's see, trapping rainwater too. Oh, Lee, what the heck is this? Somebody trying to make me do like a 2D? Yeah, give me something easier, man. Like there's people there's I think I have a solution for how to do this, but we need to be inclusive for everyone in the chat. We want to do, let's work our way up to questions, to these type of questions, and we don't want to just spam hard questions because then everyone will just be in the chat and it won't be making sense. But that's a good suggestion. Who gave that? Rock Dude? I'll drop a video on that. I'll try that out. Someone throw me a different question. How do you... Yeah, that's what I'm thinking. I'm thinking, Paul. That's what I was thinking. Like, you kind of like... Yeah, I think it'd be something like that. Dude, Paul is cracked. What do y'all think about this question? Let me bring this in. How do you know you're cooked as a CS in third year? Let me see. I don't know. I would say... Yeah, Paul, you're really good. You're really good. Damn, that's crazy. Can you do accounts merge? Yeah, sure. Let me try accounts merge. But how do you know you're cooked in a... If you're a third year student, you're still at the beginning of your career, bro. Like, even if you're cooked, you can always come back from it. So... But I have a basic recipe finder and no internships, but... Mitchell, send me your resume. Join the Discord and then send me your resume. I'll go on my channel and look for my Discord link to get access to my Discord, and then send me your resume, and then talk in the general, and I can give you more specific advice. But let's work through this LeetCode question. I don't think you're cooked, bro. Honestly. Okay, I never done this question before. Yo, Paul's good. Okay. This is a good question. Let's handle this. Yo, Paul is actually good. So given a list of accounts where each... And Paul is a graduate student, so... Yeah, dude, Paul, you're actually different, bro. I can't lie. You're probably better at LeetCode than me. So given a list of accounts where each element, accounts I, is a list of strings, where the first... Given a list of accounts where each element is a list of strings, where the first element is a name, and the rest of the elements are emails, representing emails of accounts. Now we would like to merge these accounts. Two accounts definitely belong to the same person if there is some common email to both accounts. Note that even if two accounts have the same name, they may belong to different people, as people could have the same name. A person can have any number of accounts initially, but all their accounts definitely have the same name. After merging accounts, return the accounts in the following format. The first element of each account is a name, and the rest of the elements are emails sorted. Okay. So we basically have to merge the different accounts. So we're given a list of accounts. So something like this. So these are the different accounts. For example, we're given accounts. And I need to visually look at this quick. We're given accounts. This is account 1. This is account 2. And this is account 3. And usually when you get... Tushar, thanks you. Appreciate it. Thanks for joining the channel, and let me know if there's anything that I can help out with related to pretty much whatever you want to do. I have a lot of time on my hands, so I can make videos of whatever y'all want to know and get an industry scoop on everything. So let's see. So where the first element is the name. So the first element is the name. And the rest of the elements are emails representing emails. So these are the different emails of this account. So I'm John. Now we would like to merge these accounts. Two accounts definitely belong to the same person. If there's a common email, belong. Okay. So this one belongs. Dude, I'm automatically starting to think of a union find algorithm here. If there is some common email to both accounts. Note that if two accounts have the same name, they may belong to different people. There's some common email. So the common email is here. Okay, note. There's some. Yo, Mitchell, add me and then send it over there. Or send like a Google Drive link to it. Even if two accounts have the same name, they may belong to different people. As they could have the same name. A person can have any number of accounts initially, but all of their accounts definitely have the same name. Yeah. Let me look at this LeetCode. God damn. Bro, you're crazy, man. We need to grind out LeetCode questions together and just get crazy. I think you could definitely crack like Fang easy if you're already doing hard questions in 3 weeks and you already have a good math background. So what we can do, so let's just like loop through this. So what I'm thinking is we're gonna loop through. Yo, that's so funny. Donald Trump is hilarious. Companies like Foot Locker. Is this for real? Is this for real? Companies are asking, like Geico and Foot Locker are asking LeetCode? What the industry is crazy, man. So let's do this. Basically, what we're gonna do is this is a pretty good question. What I'm thinking is, first let's work with like one element at a time. Let me just like this. I feel like the most optimal solution here is a union find, but let's just like do a very simple way, because it's been a while since I did union find too. I need to brush up on that. But what, like the reason why union find would work is it could find like, is your company hiring? Yeah, hit me up. So essentially what we're going to do is we're going to parse each person. We're going to start at 1. And we're going to assign each name a unique ID. So we're going to say John is 1. We're going to say John is 1. We're going to say We're gonna give a unique ID. John is 1. What do we need to return? Oh, the third John is different? Okay. Yeah, hit me find me on Discord. Add me up on Discord. Dude, I'll send the Discord link. Give me a second. I'm gonna send the Discord link. Where's everyone at? This is so funny. Wait, give me a sec. I'm trying to send the link. Let me get on the live. Yo, Waterloo is sick. I have so much. I know so much people who went to Waterloo too. All of our interns are from Waterloo. Hop into Discord. So what we're going to do is we're going to parse this person and we're going to keep track of like, dude, we kind of need to do a union find for this. Because essentially what we're going to do, we're going to say, essentially what union find is going to, we're going to say John has emails John Smith. Or maybe we don't need to do a union find, but let's just like walk through how we are probably going to do this. We're going to say John Smith, and John New York. Right? We're going to somehow associate this to John. So we're going to say ID1. Let's store a hash map 1. So we're going to store a hash map of all of the IDs of all the emails that we've seen and the associated user. We say this is ID1. This is I think we could do this without a union find. Let's just say we just store the IDs of where we seen that. And then we store we have like 2 hash maps. We have like one is a list of all of the IDs here. So these are the IDs of 1. And we'll put John Smith and John New York. So we'll put John Smith and John New York here. So we put John Smith and John New York here. Then what we're going to do is like then we're going to look through this one. If we see John Smith and John New York, we won't, like once we see it match somebody, wow, we need to do a union find. Yeah, because essentially how union find is going to be is when it starts looking at John, like pretend it's like John 0 at, like the only way I know how to solve this is with a union find. I don't know if it gets any, I don't know if we can do anything simpler than that. So pretend we have like John, this other John, right? And we put John here. And then we put John Smith here. Google guy in the building. What's up? So if we do John here and then John Smith here, essentially we're gonna like figure out there's this other John here. First we're gonna look at this one. It's not there. But when we look at this one, we're gonna know that we've already seen it, and then it kind of like link that over here. We need to do a union find. We have to do a union find no matter what. I just don't remember how to do that. I need to look up the boilerplate for how to do a union find. And then we can figure it out. Does that make sense? Who asked this question? Who's familiar with union find? Who asked these questions? Oh, Alex. Yo, Google guy, I did. No, Alex asked it right here. Are you familiar with union find? Let's check this. Oh, they did it with a, so this person did it with a DFS. See, a lot of people are doing union finds. I can show you how to do the union find. It's a bit more complicated, but I feel like it's the most simple way to do this question. Yeah, you need rank in order to do union find fast. I mean, let's just learn union find together real quick. I just need to quickly know the boilerplate, and then I could probably recall. Because what we're essentially doing is we're finding all... Yeah, yo, it went crazy. On the top up here, it shows my subscriber count going nice and steadily up. Yeah, we need to use union find for this. Check. But honestly, union find isn't really... Usually union find isn't that common in interviews, but that's the best way to solve this question. Damn, let me think about it. Dushin, thank you. Appreciate it. Okay. Shout out to Geeks for this. See, two sets are called disjoint sets if they don't have any element in common. See, we're merging two disjoint sets to a single set. Because essentially what's happening here is like we're gonna look through each one and we need to eventually join these two sets. Bro, it's been like 6 months since I did this union find. So let's just work through it together. How many questions do you think is good to go the next data structures? Let me answer this question first. How many questions do you think is good to go? By the way. Nice. Yo, Google guy, you're a legend, man. Yo, I would say arrays. So let's think of the different data structure. Arrays, linked list, trees, graphs, and then more specific things like heaps. And this is what Paul said. Yeah, that's good. The one thing I would say about this is arrays, you should probably spend more time than the other ones with arrays because arrays have way more questions. So pretend I only had 3 months to study. I'd literally study like 1 month just straight array questions because I think it has way more variation than like 2 weeks. 2 weeks. 2 weeks. Like, I don't know. Yeah. So let's look at this union find merging twos. Yo, I've never used LeetCode in my life. I don't know if it's good. Like somebody else who used LeetCode, let me know. Because I've never used it. Let's see what's happening. Let's see what's getting views on my channel right now. Okay. Some of my videos are still popping off right now. Yeah. Justin, what's up? Yeah, I would say use for arrays, yeah, definitely use sliding window. For arrays, sliding window and 2 pointers are in that as well. Yeah, definitely. Dude, go on like grokking the. Bro, like all the patterns are here. 2 pointers, fast and slow pointers. Once you learn all these patterns, you're gonna be able to do like any question. Yo, good job, good job. Is there any questions that you want me to find on there? Bro, this union find one, I'm gonna have to do that in a different time. Because I need to brush up on union find. It's gonna take a bit. It might take me like, I need to study it for like an hour, I would say. I kind of remember it. But you just need to... You just have to implement like... Yeah. You need to implement like a class with like... Union find, you need to implement 2 functions. Like union and find. This helps merges sets. And then find like looks... Pretty much looks up the tree. I'm just trying to do it for fun, and I'm trying to get better at algorithms and stuff too. I'm trying to get to 1,000 questions solved. Okay, I'm gonna study union find later. Anybody have other questions that they want to ask? Otherwise, I can get in. I'm gonna do some other questions. Justin, is there any questions or anything that any concept that you struggle with that you want me to try to walk through? Fizzbuzz? That's classic. Trapping rainwater 2 with a heap. Yeah, you can use a heap here. Okay, could you give me a specific question? Maybe one specific question that you tried and you couldn't do? I'm gonna drop a video on how to do recursion because I explained the recursion like live already. Okay, what's the name? What's the number? Bruh. Y'all trying to cook me on the stream. Okay, let's see. Who's asking this question? Yeah. Okay, that makes sense. Sorry, companies. Who's asking this? Google's asking this? Bro, Noor, it's because I have this Chrome extension. So I run this Chrome extension. So that Discord that you're joining in is the Discord that I started for this Chrome extension that I run. And then after I started the YouTube, I started pretty much, yeah, when I started the YouTube, I just reused that same Discord. Okay, let's try this one. Yo, Tushar, like, split array into largest. I want to do this question, but it might take a bit. Let me handle this. Yeah, I don't really know how to code BFS. Okay, let me just quickly show Justin how to solve this one, and then we'll move on to that too. Like, there's a few questions. Yeah, and also Paul, I think definitely you just use a min heap. You definitely do a. You definitely need for this. You can do a min heap BFS. So what you do is you find like the smallest element in like the smallest height in this height map, and pretty much then you check if that one is like can be part of like can trap rainwater essentially, and then you just move out from there. I don't know if that makes sense, but yeah, I think that's what you'll need to do. You'll need to like find all the low points, and then like do a BFS from those low points. You can, it's like almost like, yeah, move all directions to see if it's trapped. If it's not, then you just like return, and then like look for the next one, but you maintain some sort of scene array. That's how you would solve this one right here for trapping rainwater too. Split largest K, I think we can just like pretty much brute force this and with memoization of like finding different ways to split the nums. Like we find, so pretend K is 3, we just find different ways to split 3. Yeah, like the most brute force way is to just like split it in all possible K and figure out the minimized one. But then we can use memoization to not explore paths that we don't need to explore. And we could figure that out after too. But let's work through like a simple breadth first search. So Yosh, let me send you, if you're a noob at breadth, or if you're a noob at DSA, I'll send you a video to help improve that. Yeah. So we're gonna do a level order traversal. So in order to do a level order traversal, so one thing that everyone should know is when you're doing a BFS, we use a queue. When we do DFS, we use a stack. If you're doing anything like Dijkstra's, we use a heap. But the algorithms are essentially the same. So since we want to do a breadth first search, essentially what we're gonna do is like pretend we have like 1, 2, 3, 5, 4. We're gonna do a breadth first search, and breadth first search lets us explore all of the nodes level by level. So what we're going to do is we're gonna do a level order traversal, and to do a level order traversal on this, we're gonna maintain some queue. We'll capture the base case. If root is none, just return. If the root is none, just return empty. Otherwise, what we're gonna do is we're gonna do a level order traversal. So we're gonna do a queue, and we're gonna add root to the queue. Pretend we have a queue, and we add root to the queue. This is our queue. We're doing a breadth first search. So we want to explore 1 first. So what we're gonna do is like, we're gonna be like, while the length of the queue is greater than 0. That means there's elements in the queue. And then what we're gonna do is we're gonna have like some sort of result. And then eventually we're gonna return that result. So what we're gonna do is like, since 1 is at the top of the queue, we're gonna run through all the elements in this first level. So how we're gonna do that is, usually how I do this is I say for so that's the length of level, and then we'll say for index. So pretend the length of level is 1, 2, and here is 2. So what we're gonna do for index in the range of length of level, what we're gonna do is like, so when we capture these variables, length of level is gonna be 1. So we're gonna loop exactly 1 time, right? And you'll see how this is gonna work. So we're gonna loop exactly 1 time. If the index minus 1, or if the index plus 1 is equal to the length of level, we say result dot append. What we're gonna do, we're gonna take our element from the queue, pop left. Queue is a first in, first out. So when we're iterating through the breadth first search, we're always gonna want to pop from the front of the queue. So that's what pop left does. We'll do candidate. If the index plus 1 is equal to the length of the level, we'll do candidate result plus candidate dot value. Candidate is like the element we popped out of the queue. So since we popped it out of the queue, we're now looking at this root 1, and it has pointers to left and right children. And then we now remove that out of the queue. So now we're just looking at this element. And then since it's like the last element in this row, we can add it to our result. But essentially now we need to figure out if we need to add its left and right children into the queue. So we say if candidate.left then queue.append. Dot right. So if the candidate dot left, then we pop it there. So 1 has an element to the left and an element to the right, so we pretty much add those to the queue. So we do left and then we do right, and then yeah, now that's in the queue. So now in the next iteration, we're gonna pop the front element again. Run that. Wait, queue.pop left. Oh, we're gonna, to use the queue, use dequeue from. So it'd be something like that. And let's like walk through. Does that make sense? So let's like walk through the algorithm. Since we're popping from the queue, like we looked at 1, and now we popped 1 and we looked at its left and right children. And since it's a first in, first out, we're always gonna explore 2 and 3 first, because those are the first ones that we popped in the queue. So since they're the first one, okay, that's good, that's good. But yeah, hope that makes sense, whoever asked this question. Yeah, Justin, does that make sense? That's the algorithm. Let me drop you Let me drop you my video. Let me drop my video where I actually explain this more like thoroughly. Yo, watch this video. Watch this video. And then try to understand trees better. I'll show you different. Did that make sense? What I did there? Trees. I think all you literally need to remember and understand is why, like, using a queue helps you move in this manner. Because essentially when you use a queue, when you add the left and right neighbors or when you just add the neighbors of a specific node, you'll always visit it first because you pop them into the queue first. So you'll always end up looking at them first. Alright. What other questions do people have? Right here. This is where it is, right? And then also the other thing that I'm doing different is like I'm looping through each level one by one before I move on to the next one. Try doing this question called level order traversal first. And then like modify that one. Okay, do this question first. Yeah, I could explain this one. Oh, let me stretch. Bro, give me a sec. Let me stretch out. I've been on this stream for 3 hours. Wait, 1 sec. I'm just moving I'm gonna put my standing desk up. It's crazy. Bro. I'm hit the gym soon too. Yo, I'll be back online. I'm gonna hop off in like 30 minutes and I'll be back online. Yeah, I could show you those too. Let me stretch. Oh, yo, I'm gonna do the weekly contest today. I'm gonna stream the week. Yo, let me start streaming the weekly contest every Saturday, and everyone hop on, and we'll do that. We'll do it together, and try to like get really good at those. Because somebody told me a hack yesterday on how to get good at LeetCode, and he said this is a very systematic way to get good at LeetCode, and it actually made a lot of sense. Yo, this Farzan guy, he's good. So yesterday he told me, he's like, there's a very systematic way to get better at LeetCode that no one really seems to talk about. He said you have to do LeetCode contest and then use the zero track to practice problems rated 100 to 200 points higher than you. It's like the same way that people get good at chess. They literally figure out their elo and then they just face people who just have slightly higher elo than them until they get good enough and they beat that and they like slowly move up. That's kind of how this guy says you can systematically get good at LeetCode. And I think, yo, Paul, did you see this? I think this is actually smart, really smart way to do this. So you pretty much, I'm gonna post this. So do contest numbers, and then like use this zero track to figure out problems that are like 100 to 200 points higher than your rating. And then, yeah, I'm gonna start doing the contest as well. Okay, yo, that's interesting. I haven't done contests. Okay, I'm gonna explain this one question, and then I'm gonna hop off, and then let's get back on in 5 hours and do the contest. That's what I'm gonna do. Yeah, I think you're already good, man. Like once you already get that good, you're good. Yo, Noor, no problem. I hope you learned something from the stream. I'm gonna handle the course schedule for Finn. Yeah, getting the interview is hard. Honestly, it's a lot of like having the right clout. That's why a lot of the people who just message me, I'm just like, how's your social media? How's your LinkedIn presence? How's your resume? You kind of have to just put yourself out there a little bit. Yeah, I think doing LeetCode will definitely keep your brain sharp because this is like little puzzles. Okay, let me get into this question for who asked this question? Finn. So the best way to solve this question is using a topological sort. And I'll explain how exactly to use that. Topo. Have you ever heard of that term, Finn? Have you ever heard of topological sort? Yeah, exactly. Okay, I'll explain it. What the heck is it? I'll explain it like simply. Yeah, just like message them through LinkedIn. Let me put the chat here. Message them through LinkedIn. So first off, when we're doing this, we're trying to see there are a total number of courses. I'm gonna move this out. Yo, I haven't even ate all day. Just grinding this thing out. But I'll be back in. I'll be back in at 6. So there are a total num courses you have to take labeled from 0 to courses. You're given an array of prerequisites. So you're given an array of like prerequisites. AI has to be done before BI. And then you must take the course BI. So let's just like think of this as a graph. Pretend we have like, let's just use actual courses here. Let's just say like say we need to do intro to Java. No, we're gonna do course 1. We're gonna do one first. So pretend let's just use courses here like CPSC 101. CPS 201. CPSC 301. So these are the different courses. And then what else do we have? And let's label this. Let's just say like math 101. So this course schedule is essentially a graph problem. These different prerequisites tell you the edges between all of the different courses. So pretend these are the different courses that I have to take. I have to take 301. I have to take 201. I have to take 101. Math 101 and 201. And basically the prerequisites array is telling us what needs to be a prerequisite of another one. Like if we have AI, BI indicates that you must take BI first if you want to take AI. So let's say that like in order to take 201, before you take 201, you need to have taken 101. Before you take 301, you have to take 201. Before you take 101, you need to take 201. Or let me mix this up, sorry. Let me reverse this. So before you take Math 201, you need to take Math 101. So basically, parsing out the input will give us a graph like this. It'll give us a graph and it'll tell us the dependencies of the graph. Basically the prerequisites of the graph. So when you look at this like a normal graph, the way I think of topological sort is it's basically like a reverse depth or a reverse breadth first search. So it basically pops things out in a breadth first search manner, but goes from the bottom of the tree. Like why do we, like if we're doing a breadth first search, we can pretty much start at the top of the tree and then like go down. But in order to solve this problem, we need to knock off the courses that have no prerequisites. So we essentially need to find all of the elements. We need to find all the elements that we can do right away that don't have prerequisites, and that will free up all of the other elements to do. So pretend we essentially need to keep track of in degree, or we just need to keep track of like the out degree. And out degree tells you how many like outgoing edges it has. So once we basically what the topological sort is you start the queue, you start with a queue, right? And then you add all nodes with 0 out degree. Because if it has 0 out degree, that means that we could take that course. That means there's no prerequisites to take that course at all. So we can start our queue with pretty much CPSC 101 and MAT 201. So we add all nodes with an out degree. And then like essentially we do like a breadth first search where like while isn't it 0 in degree? No, it needs to be 0 out degree, because out degree is like how many edges is going out of it. So this one has an out degree of 201 because it's pointing to somebody. I think that's the terminology. So essentially what we're going to do here is we're going to look for all nodes with 0 out degree, and then we're going to process those nodes, and we're essentially going to be like, we're going to basically complete those courses. So pretend this one has an out degree. Let's do CPSC. Let's add another course right here to the side to just make this more complicated. So we're basically tracking. Let's see. So essentially we add all nodes with a 0 out degree. So that's going to be CPSC 101, CPSC 202, and then Math 201. Those are all of the ones with no out degree. We add that to the queue, right? And then we'll be like, while the length of the queue is greater than 0, we're gonna run like basically a breadth first search, where we're just doing like, when you add it into the queue, that means it's ready to be that course is ready to be done. Like like you've already completed all the prerequisites. Since these ones have no prerequisites, that means we could just do it right away. So we popped in all of these, and then we're just gonna process them one by one. And let's say we maintain like some sort of out degree here. So this one has 0 out degree, this one has 1 out degree, this one has 1 out or 2 out degrees, this has 0, this has 1, this has 0. Since all of these have 0 out degree, it has a 1. Mat 201 has an out degree of 1. So these are the out degrees. 301 has 2 out degrees, 201 1. So basically all the ones. Yeah, we need to go through all the prerequisites to build this dependency graph, and we need to store the out degrees. And then basically we pop into the queue any element whose out degree is equal to 0, and then we start processing it. And we need to keep track. Also need to keep track of the parents. So basically, let's like pretend we process CPSC 101, right? Now that we process CPSC 101, we can reduce the out degree of CPSC 201 by 1 because we just did a prerequisite. So we can reduce this to 1. Mat 101 is... Oh, sorry. I messed it up. Sorry, I messed that up. Yeah. Mat 101 should be in a queue. Sorry. So all the ones with 0 should be in the queue. Yeah, exactly. You're right. So now we process 101, and then we could like reduce 201's out degree to 0 because we already did 101. So we kind of need to track... Yeah. Exactly. So now, pretend now we have 0. Now since CPSC 201 has 0, we could actually add it to the queue. Since Mat 201 it got to 0, we can, or CPSC 201 got to 0, we can add it to the queue. Right? And now let's just keep going. CPSC 202. Right? CPS 202 has a 0 out degree, so we'll process that, and then we'll reduce like its parent by 1 because that means like we've already checked this one off, right? But can we add CPSC 301 to the queue yet? No, because we haven't been able to it still has a in degree of 1. That means we didn't really take all the prerequisites yet. Okay, now we move on to Mat 101. We finish Mat 101. And then we update the parents, we subtract 1 from it. So we get 0. Since Mat 201 is 0, we can add it to the queue. Oh, shoot. I just need to move sideways. So since Mat 201 is 0, we can add it to the queue, and then we can like track that. Now we do Mat CPSC 201. Right? Then we update its parent to 0. And then we check this off. And then now we can process 301. Now we can do Mat 301. So that's kind of what a topological sort is doing. It only adds things to the queue when the out degree is 0. So we just need to keep track of out degrees and parents. When and then I'll implement that. When after 0 we add. And then okay, how do we, and essentially for this, that will like the same algorithm will answer both 1 and 2 because 1 and 2 kind of just tells us what order we need to make them run. But like for course schedule 1, essentially pretend there's a loop here. Pretend there's a loop here. Pretend there's a loop here. Yo, Chester, it's crazy, yeah. It was a good night. It was definitely one of my best nights in a while. I literally just woke up and it just went ham. essentially what we want to do is like we want to return true if we're able to process all the nodes. Bro, you want to check the stats? Let's look at the analytics. I had a few videos blow up, honestly. It just popped off. Like I got 4,000 views in 1 second. The videos that are really popping off right now are this like senior software engineer takes on Meta. I don't know why people like this one so much, but I feel like a lot of people subscribe to this one. I had so much people subscribe based on this one, and this one has like been blowing my channel up. So that one popped off. And another one that popped off is Silicon Valley. Yo, people like this one. Yeah, people really like this one. How to write it. This one already has let's see. Bro, like this one already is popping off. This one has 4K views. So yeah, people really like this how to write a resume for software engineering roles. Bro, yo, just let me know what's it called. Why did y'all like that? Why did y'all like that interview? I'm trying to figure out why people like that one, and if I need to do more videos like that. And like, please suggest me other content. Like, why did that one make y'all click? Yeah. I got more of that. I got more of that coming. Like, I wonder why those popped off. Yeah, I wonder why that one popped off hard. But even like this one called, yeah, I'm down. Bro, I have this Silicon Valley engineer takes on a quant interview. And that one worked. And then I have like that, this one actually did some good numbers too. And it's still doing a good amount of numbers. People like this one as well. So I have ones coming for like Google, Microsoft, Bloomberg, Amazon, like whatever y'all want. I'll even do like OpenAI, Anthropic, like whatever. I'll do a bunch of those because they seem to hit. So that's kind of like why my channel popped off. That was a bit of a tangent, but let's get back into actually implementing this. So I said that we're going to build a dependency graph of parents. So I said we need to keep track of parents. We need to keep track of out degrees. And then we're going to use like some sort of queue to run our topological sort. Right? So basically what we're going to do is we're saying you must take course. Which first loop? Yeah, no, I'll explain the whole thing, and it will make more sense as I implement it. I hope like this like long explanation of the theory works or made sense. I think you kind of just need to see how the code runs in order to actually implement it. Get my water. And yo, everyone, hop on later at night. We're gonna try out the LeetCode contest because we're gonna try to get our elo up. So what we're gonna do is like we're gonna loop through the prerequisites. Yeah. You could do. Oh. Okay. Yeah. You're right. Okay, that's important part. Basically, for course schedule 1, we're gonna be like true because we have to return just a true or false here. True if we can finish all courses, false otherwise. True if we can process all nodes, false if we can't. Okay, pretend there's a loop here. We said that we're just gonna let's count the out degrees. This has an out degree of 0. This has an out degree of 1. This has an out degree of 1. This has an out degree of 1, right? We're gonna take our queue and we're gonna pop in. We're gonna take our queue and we're gonna pop in CPSC 101 because that is the first. That's the only element with an out degree of 0, right? Once we pop 0, like once we pop this out, we can reduce the count here to 0. Now we have 201 that's ready to go. As soon as it hits 0, we pop this out of the queue and we process that part of the queue. We do 201. Or sorry, this has a, I messed this up. This has an out degree of 2. So this has an out degree of 1. This has an out degree of 2, right? So we process 101 and now we're at 201. Now when we get to 201, we can reduce this to 1 and process 201 right here. And now you see we only reduce this to 1, but we only want to pop things into the queue if it reaches 0. So now we can't even pop anything left in the queue. So our algorithm kind of ends here, like, because the queue is empty. Because what we said before is like while the queue has elements, now the queue is empty, but there's still two elements to process. So since there's 2 elements to process and the queue is empty, we return false. So we kind of just need to keep track of how many nodes we've processed. And you can see why, like, when you add the cycle a cycle there, it just no longer works. That's kind of like a, like, topological sort definitely helps you find cycles. Does that make sense? I'm waiting for anybody in the chat to just give me a thumbs up if that made sense. Alright, I'm gonna assume that all made sense. Let's like actually implement this. So you are given a total number of courses you have to take. Labeled from 0 to num courses. You are given a prerequisites array. So you're given a bunch of elements, prerequisites, where AI indicates that you must take BI before AI. So essentially what we're saying is like AI is a node here. And then we have to take BI. We have to take BI. You must take BI first if you want to take course AI. So that's like, we're going to pretty much build out this graph like that. So we're going to say, like we said, we're going to store for parents. So we're going to say AI, B. And sorry, the chat is a little slow. I don't know why. Let's just make sure that runs. No, we're doing a topological sort E. So we're doing, and I'll like clip this video so you can understand topological sort if you haven't done that before. So we run topological sort. Okay, 1 and 0. So what we're saying is AI depends on BI. So we're gonna from. We're going to say parent, or out degrees is we're going to say, we're going to be like out degrees equals a dictionary, and then we'll say for I in range. Num courses. We're gonna set the out degrees with each I. We'll just say to make the variable names better, we'll do course ID. So we'll start with the out degrees of all the courses at 0, and then when we when we parse the prerequisites, we'll update like the out degrees of each course. So, and then parents is just going to be like a set. Parent. So we're going to do like parents, because we could even like for this example, a valid one would be like this is also valid for this question. It's not, we don't have a bunch of trees here, it's a graph. So like CPS 201 could be a prerequisite for 101, so it could have multiple parents, so we need to store that in a list. So we'll do default dict, we have a list. So what we're gonna do is like initialize out degree, and we're saying for AI and BI, first you must take BI if you want to take course AI. So we'll say like here we say AI BI, so we say the parents of BI dot append. So I'm basically saying AI is a parent of BI, right? Then I'm saying out degrees. I'm saying out degree of AI plus equals 1. So that builds like the parent set. So now I know all the parents, and then I also know the out, and I'm also keeping track of the out degrees. So now I built my dependency graph. So we're saying, yeah, does that make sense so far? So we're saying indicates that you must take BI first. So I'm saying BI has an out degree of 0, but what are the steps? I'm gonna send you my video on how to get good at LeetCode. That's like my way that I would do it. And order doesn't matter for this. Dude, let me find. This is my how to get good at LeetCode. And I'm dropping more different videos on all the different algorithms as well. So we have our out degrees. We're saying out degrees of AI. We add 1 to that, and then we say the parent of BI is AI, so we can figure that out. And then now, like I said, we're gonna be from collection. We're gonna be using a queue. So we start a queue empty, and we say for node in out degrees if the out degrees node, if it has 0 out degree node, right? And we're gonna have to maintain a scene array. What we're gonna do is if the out degree is equal to 0, we're gonna pop that into the queue. And then what we're gonna do is we're gonna say we seen it, or do we need? Yeah, we can do scene.add the node. So that just initializes the queue with all of the elements that are equal to that like have no dependencies, and then we're gonna start taking all those courses. So we're gonna say while length of queue. So I'm gonna keep doing this while the length of queue is equal to 0. And then after, I'll return true if the num courses equals the. So basically what I'm gonna do is I'm gonna return the answer is gonna be like if I'm able to see do all the courses, that means it's true. If I can't, that's false, because we just need to see if we could actually finish all courses. So scene is keeping track of what courses we've seen, or let's just call it finished to help people out. Finished. So we have finished here. And maybe let's not update here. But what we're going to do is like, if the length of finish equals the number of courses, we return true. Otherwise, we return false. So what we're going to do is we're going to take our, we're going to take a course that like is able to be finished. We're going to basically go to our queue and pop left. That means we want to take that course. And then we're going to say finished dot add the course. That means I think we might have to do this. I think we might need to add it to the scene array as soon as we do the course, but to make it more optimal. But let's just do it. So we say we pop the left. That means we're gonna take one of the courses that are good and we add it to finished. And then, like I mentioned, we're going to look at the parents and reduce their out degrees by 1 because we already completed that course. So I'll say for in. So for parents and the parents of the course, what we're gonna do is we're gonna take the out degree of the parent, and then we're gonna minus equals 1 because we did a prerequisite. That knocks off a prerequisite. If equals 0, what we're gonna do is we're gonna, if like we reduce it and it hits 0, what we're gonna do is we're gonna say we're gonna take our queue dot append the parent. See if that works. Does that make sense? That's kind of how you would implement it. It's actually simpler than it looks, and I hope the explanation I did there kind of makes sense. And then all we need to do to solve course schedule 2 is, instead of returning just if we finish all courses, the main difference here is it wants you to return like an order that is possible that you can take. So what we need to do here is pretty much we can use the same algorithm. And we can all we need to do is like store a result and pass and return this result. And we just say so that's how you solve the. Oh, what happened? Wait, let's see. Oh, if. Oh, sorry. Oh, we need to return if. There you go. That's how you do topological sort. Holy, we covered a lot of ground in just this. Anybody have any questions? Taking questions in the chat. Let me know if I need to explain anything deeper. Anybody have questions on that? Yeah, but did you understand topological sort? Yeah. It's hard if you don't understand topological sort, so just implement it a few times and get an understanding, and then yeah. But you guys, I'm gonna be on again later. I'll be on in like 4 hours to work on the stream, or to do. Could you some? Yeah, you could do, Paul, you could do the same thing with in degree as well. Let's see. You can use in degree. No, not really. You can't really use the in degree because how do you know when you could take one? I think you have to use out degree. I think you have to use out degree because like you can process this one, right? But it has an in degree of 2. Like there's 2 nodes pointing to it. So you kind of have to use the out degree because out degree basically out degree is how many prerequisites does it have. If it has 0 prerequisites, that means I could do the course. And then I could reduce the number of prerequisites needed for my parents after I solve that specific course. So pretend like 301 initially has 2 prerequisites. After I finish 201, it only has 1 prerequisite left. So you kind of need to... Paul, honestly, I'm not exactly 100% sure if we could do that. Like let's look up topological sort. Let me bring up ChatGPT. Damn, I messed it up. And the number of outgoing edges. Maybe I'm messing the terminology up. I think for this one we have to use out degree though. Really? Okay, I need to refresh that. That's how I usually solve this question. Interesting. Yo, okay. Everyone, hop back on 6:30 PST. We're gonna do the LeetCode competition. Yo, good job. Sapik, what did they ask you? Dude, actually, what's it called? Which ones did you like? Like which meta questions did you like? Dude, I did one that was crazy. I did one. Dude, I did this 2-hour one when I literally just reviewed every single meta question. What's 50Q stream? What's 50Q stream? Is this the one that you watched? Oh shoot, this is wrong video. Dude, I'm gonna do these for all the fan companies then. Yo, I literally reviewed 50. The practice one. Oh, and 50Q stream. Yeah. I'll do that for all the fan companies. Yo, what did they ask you? Yo, actually add me on Discord. Yeah, let's get it. Yo, that's sick. Bro, in like literally 2 hours, I just like looked over all the questions and figured out like a simple solution for all of them. And then I also looked at the comments. Yo, I'm so happy that you cleared your Meta phone screen, bro. Yo, join the Discord community. Yo, join the Discord community. They only ask you one question? I thought they like to ask 2 questions. Dude. They wanted you to do it in breadth first search. Here, let me see. Yo, join our Discord community. Let's just go ham. I'm gonna send it in the chat. Yo, were they satisfied with using a BFS? Hell yeah, Paul. Bro, everyone hop in the thing. Damn, okay. I should probably share that with the community. Like, if you're interviewing at Meta, understand all of the different solutions. That's crazy. Yo, good luck on your on-site. You got this, bro. Alright, yo, hop on at 6:30. We're gonna do some studying. Nice work. Yo, I'm so happy that you cleared the screen. Good job, man. I'll see y'all in the next stream. We're gonna hop back in like 4 hours. Peace.